Hello there, fellow math enthusiasts. Today we are going to take a look at the Pythagorean identity and radian reference angles. So first of all, when we talk about our Pythagorean theorem, we know that in any right triangle, we can go ahead and say that x squared, I don't want to say that. Hello there, fellow math enthusiasts. Today we're going to take a look at the Pythagorean identity and radian reference angles. So first of all, in any type of right triangle, we know that we can use the Pythagorean theorem, that a squared plus b squared is going to equal c squared, or the leg squared plus the leg squared is equal to the hypotenuse squared. So if I take a look at this triangle that I have that is drawn in standard position, I could go ahead and say that x squared plus y squared is equal to r squared. Now if we go ahead and we move into the unit circle, we know that the radius is going to be equal to 1, and we know that the x value is going to be equal to the cosine of theta. If I go ahead and say theta is right there, and that y is going to be equal to the sine of theta. That's something that we talked about yesterday, which makes this coordinate up top here the cosine of theta, and then the sine of theta. Keep in mind x and then y, cosine and then sine. It's alphabetical order for both of them. So when we move into the unit circle, the Pythagorean theorem becomes what we call our Pythagorean identity. Instead of saying x squared, well, we've got the cosine squared of theta. And instead of saying y squared, we've got the sine squared of theta. And since r is equal to 1, we've got that is equal to 1. So our Pythagorean identity is cosine squared plus sine squared is equal to 1. Now, one thing I want you guys to go ahead and note is the notation here. It is not the cosine of theta squared. Those are two different things, okay? So this is the cosine squared of theta. Now, I want us to go ahead and to think about our different quadrants here for a moment. In quadrant 1, we know all of our points are going to be a positive x value and a positive y value. In quadrant 2, it will be a negative x value and a positive y value. In quadrant 3, it will be negative, negative. And in quadrant 4, it's going to be positive, negative. Now, if we think about it for a moment, the cosine values we know are our x values. So in quadrant 1, the cosine is positive. In quadrant 2, the cosine is negative. In quadrant 3, the cosine is negative. And in quadrant 4, the cosine is positive. With our sine values, we know that the sine is the y value. So in quadrant 1, the sine is positive. Quadrant 2, the sine is positive. Quadrant 3, the sine is negative. And quadrant 4, the sine is negative. Now, thinking about tangent, tangent is sine divided by a cosine. So a positive divided by a positive, the tangent is going to be positive. In quadrant 2, a positive divided by a negative, the tangent is going to be negative. And in quadrant 3, negative divided by negative, the tangent is going to be a positive. Quadrant 4, a negative divided by a positive, the tangent is going to be negative. So I've got all these positives and negatives, cosines, sines, and tangents. It'd be really nice if there was a way to go ahead and remember where the cosine, sine, and tangent are positive and in what quadrant that happens. Well, if we take a look, all of the values, all of the trig functions are positive in that first quadrant. So I'm going to go ahead and I'm going to say all of them are positive. In the second quadrant, only the sine is positive. In the third quadrant, only the tangent is positive. And in the fourth quadrant, only the cosine is positive. So first quadrant, all of them. Second quadrant, sine. Third quadrant, tangent. Fourth quadrant, we have the cosine that's positive. Okay, we have A, S, T, C. I say all students take calculus. This little device helps me remember where each of the trig functions are going to be positive. In quadrant 1, all of them. Quadrant 2, the sine. Quadrant 3, the tangent. Quadrant 4, the cosine. All students take calculus. And I do this little ASTC when I go ahead and I start the next problems. So with these next problems, it's going to be a lot of calculator button pushing. All right, I want to find the values of cosine and sine to the nearest 10,000th. Keep in mind 10,000th, that is 4 decimal places. And I want to be able to indicate which quadrant each of these values are located in. So I'm going to give you that the cosine of theta is equal to 0.5437. And I'm going to do my little all students take calculus. And if I'm talking about a positive value here, I know that this is going to go ahead and it's going to in either quadrant 1 or in quadrant 4. Because all and calculus, that's where the cosine is going to be positive. Now, I know that my Pythagorean identity, we've got the cosine squared of theta plus the sine squared of theta is equal to 1. And I'm going to plug in what I know now. 0.5437. That's my cosine value, squared plus the sine squared of theta is equal to 1. Now, we want to be able to go ahead and figure out what sine is equal to. So I'm going to move that 0.5437 squared on over. That is the sine squared of theta is equal to 1 minus the quantity 0.5437, all of it squared. Now, I'm going to write out each of these steps. All right, we're going to do that just once, and then we're going to go ahead and in the future just be able to write it out on our calculators or punch it into our calculators to go ahead and figure out what we're going to be doing. All right, so when I go ahead and I do that, I'm going to punch in that that is 1 minus the quantity 0.5437, all of that squared. And notice that I get 0.70439031. I'm going to write out all of that. And again, you won't be doing this in the future. This is just for note-taking purposes. So 0.70439031. And then to undo a square, I'm going to take the square roots. And I'll see that the sine of theta is equal to, well, let's go ahead, let's do that, the square root of that answer will give me 0.8393. Now, since I'm taking the square root, that is a plus or minus 0.8393. So I've got two values here. So the sine of theta is going to be equal to something, and this is where our quadrants come back into play. In quadrant 1, and it's going to be equal to something in quadrant 4. Well, I've got a positive 0.8393, and if we think about it, quadrant 1, that's where all of the values are going to be positive, so that's where my positive one is going, 0.8393. And in quadrant 4, well, quadrant 4, only the cosine is positive, which means the sine is negative. That's where the negative 0.8393 is going. Now, when we talk about our quadrants, we go ahead, we use Roman numerals. We write out quadrant 1, quadrant 4. So what you see right here, that's exactly how I would expect to see it on your homework, and it's exactly how I would expect to see it on a quiz or a test. All right, let's go ahead, let's try number 2. Number 2, we've got the sine of theta is equal to 0.4828. Well, if we go ahead and we take a look, the sine is positive in the first and the second quadrant, which means if I'm looking for the cosine of theta is going to equal something in quadrant 1, and it's going to equal something in quadrant 2. So if we use this cosine squared plus sine squared is equal to 1, we've got that the cosine squared of theta plus 0.4828 squared is equal to 1. And we're going to do all of this on our calculator now. We're going to say 1 minus that 0.4828 squared. We'll click enter. That's what the cosine squared is equal to. So now we've got to go ahead. We've got to take the square roots of that value. And we get that that is 0.8757. So the cosine of theta is equal to plus or minus 0.8757. Now the positive one and the negative one, we've got to figure out where that goes. The positive value, well, in quadrant 1, all of them are positive, so that's where the 0.8757 is going to go. In quadrant 2, only the sine is positive. That means the cosine has to be negative. That's where the negative 0.8757 is going to go. All right, so the work that I've shown here for number 2, that's the work that I would expect to see on your homework and also on your quizzes and your tests. Let's go ahead, let's flip it on over. Now we can go ahead, we can move outside of the unit circle, and I'm going to tell you that an angle in standard position, it terminates at the given point. I want to compute the exact values of the sine, the cosine, and the tangent. So I've got the point 6,8. We are in some circle. It is not a unit circle, but it is still centered over the xy axis. The point 6,8, well, that's in the first quadrant, so 6 over 8 up, right about here. And we can go ahead, we can draw in our triangle. Keep in mind that is a right triangle there. Here is our theta. Our x value is 6, so that's going on the x-axis. 8 is our y value, so that's going on this part of the triangle right here. And then we need to figure out what our radius of the triangle of the circle is, or the hypotenuse of that triangle. We can either do the Pythagorean Theorem, 6 squared plus 8 squared is r squared, or hopefully you recognize that as a triple, 6, 8, 10 is a Pythagorean triple. So if we want to go ahead and we want to compute the sine, cosine, and tangent of theta, your final answers are the only answers that I would like on the line. Everything else you can do off to the side for your work. So the sine of theta, well, sine is the opposite over the hypotenuse. That is 8 over 10. 8 over 10 we will know reduces to 4/5. The cosine is the adjacent over the hypotenuse, so 6 over 10. 6 over 10 we know reduces to 3/5. And the tangent is the opposite over the adjacent. That is 8 over 6. 8 over 6 will go ahead and reduce to 4/3. All right, now that was a pretty basic one. They're not all going to be that simple. All right, especially if we've got stuff that goes ahead and moves into other quadrants, we are going to have to take into consideration our negative values, and we're not always going to see that it's going to be a Pythagorean triple. All right, so I'm going to go ahead, I'm going to pause this video right now, and you can pick up numbers 4, 5, and 6 on the next video.